This compound is given here. It has many substituents. We have nitro, fluorine. There's a carbon here which is attached to bromine and methyl. This nucleophile is given here, pH S minus Na plus. Sulfur comes in the same group as oxygen, so behaves quite similarly to oxygen. So this is kind of similar to this nucleophile. That is sodium phenoxide, we call this nucleophile. So this one can be called as sodium thiophenoxide. Sodium thiophenoxide or phenolate. Or sodium thiophenolate. So that is the nucleophile here. It's a strong nucleophile. Dimethyl formamide is also given in the reaction, DMF. It's an aprotic solvent. An aprotic solvent meaning the mechanism is SN2 mechanism. Considering all this, let's see our options here. First of all, there are two halogens present on this compound. One is fluorine and the other one is bromine. SN2 meaning substitution, nucleophilic substitution. So therefore, it should be replaced by SPH, which is the negatively charged part here, nucleophile here. Now fluorine is present on benzene directly. So this can be called as an haloarene. Whereas Br is present on the side chain, especially this is a benzylic carbon here. And therefore, this can be considered as a haloalkane. We know that haloalkane is more reactive than haloarene. Therefore, this will react. This will not react. We also observe here that bromine is on wedge bond. Like this bond. This is called as wedge bond. In SN2 mechanism, we see inversion in configuration. So, the attacking nucleophile SPH will be attacking from the opposite side. So, if Br is present here, SPH will be attacking from the opposite side. This we can show in our structure by drawing a dotted bond which is in the opposite direction. Considering our options here, in option A only we are seeing NO2 is intact, fluorine is intact, here one methyl is there, and we are observing that SPH has attacked from opposite side shown by this dotted or dash bond here. So inversion has occurred here, SN2 mechanism has occurred here. In none of the other structures I am seeing that type of dotted bond, hence option A is the correct answer.